In this video, we will demonstrate how our project circuit works. Here, I have the dimmer control voltage generator ESP8266, an op-amp circuit, and we have two sensors. One of the sensors is in Edirne and the other sensor is in Kocaeli. So, let's begin our demonstration. To start with, the magenta cable shows LED 1 and the yellow cable shows LED 2. Now the circuit is off because the web interface is off. Now I will ask my friend to open the web interface, but before I will measure the outputs of our control voltages. So as we can see, the voltages are equal to 0. So let's open our circuit now. Now that the web interface has been activated, the control outputs will start with half of the total control voltage, which is 10 volts. As you can see here, the output of LED 2 is 5 volts and the output of LED 1 is 5 volts too. This is something we embedded in the code of this microcontroller. Every time the circuit starts functioning, it starts with half brightness. It gives half brightness to the LEDs. Now, since the web interface opened in manual mode, we will manually adjust the LED brightnesses to 70%. So, let's have a look. Yes, as you can see, the voltage of the second LED's control voltage is nearly 7 volts, which means that the manual input has been successfully transferred to our microcontroller via the internet. And you can see that for LED 1, the voltage is also close to 7 volts, which is equal to 70% of the total control voltage, maximum control voltage. So let's try again. Now we can input 30% LED brightness. So 30% LED brightness has been inserted, and let's check it out. Yes, it can be observed at the LED outputs for the LED 2 and for LED 1. These are the control voltages that drive the dimmer. And now, we did our experiments for the manual mode. Now we can switch to auto mode. In auto mode, the brightness control is under the influence of the incoming sensor values. Now, let's wait a little. We have not arrived any sensor values yet, and that's why the circuit is still demonstrating the old sensor values. Now I can see that, yes, well, the control voltages have changed, which makes me think that the LEDs are lit up with full brightness, since the voltages are close to 10 volts. I can see it on the web interface too. Yes. So both LEDs are in the dark and they are lit with full brightness. Now I will ask my friend to change the light that falls on the LDRs. He will use his cell phone flashlight to change the light falling. I can see from the sensor data on the web interface that the first sensor has a lower sensor index, which means that it is under a brighter condition than before. Yes, as we can see on the web interface, that the first LED is lit with 60%, which is, no, it is lit with 50%. Yes, now I can see it better. The first LED is lit with 50%, and the second LED is used with full brightness. Yes, as you can see from the multimeter too. And I would like to ask my friend to change the sensor brightnesses, the light falling on the sensors in such a way that we can see some 80 or 60%, and yeah, there it is. I can see a 60% at LED 2. Let's check it out. Unfortunately, it has dropped to 50% now. But still, the circuit and the microcontroller is reacting to the changes in the light brightness, and the LED 2 brightness, as it can be seen. LED 1 is in a dark environment now, so it's lit with full power. I say it is lit with full power, but what I mean is the LED dimmer driver inputs a voltage close to 10 volts, which controls the LED brightness, and it's like a tap. The more you open it, the more light you get. So, yes, now I can see at the output of the second LED control voltage 60% brightness, as you can see from the multimeter too. So, finally, I will ask my friend on the other side of the communication to end the system running. And he has turned the system down, and as you can see, the control voltages are equal to 0. Thank you for listening, and have a nice day.